Hello everyone, my name is Sagar Tiwari and the topic for my project is email spam filtering using supervised learning algorithms. The internet came into existence in the late 1980s and since then it has connected people across the globe. Reverse engineering the internet seemed a whole lot of fun for some people, but this also included people with malicious intent. People have started using emails to spread the word about their businesses to attract potential customers. What is a spam email? Unwanted emails that are sent anonymously, mass mailed, and are unsolicited fall in the category of spam. Some hackers use spam email to extract information from the user. This information may be financial, personal, or could be professional. Victims of spam emails have collectively lost more than $15 billion in the past year. There are several kinds of spam emails, but I have mentioned 4 popular ones here. Spam-vertised sites. As the name suggests, these are the kind of emails that advertise products. They contain URLs to other websites. Phishing emails is basically extracting financial information from the users by asking users to enter their legit bank information on a fake website. 419 scams. These kind of spam emails offer huge sum of money to the users in return for a small initial payment. Image spam. In these kind of emails, the content or body of the message is displayed as a GIF or JPEG image. Spam detectors, who basically detect emails as spam based on the kind of text in the body, are unable to detect these kind of spam emails. Key terminologies before we move further into the algorithms. Spam emails are the unsolicited junk emails. Ham emails are non-spam emails which contain legitimate content and are of importance to us. Accuracy is the extent to which the algorithm correctly predicts an email as spam or ham. False negative is when a spam is falsely classified as a ham email. False positive is when a ham email is falsely classified as a spam email. Execution time is the total time taken by an algorithm to execute completely. In my project, I have discussed 3 algorithms: the knife-based algorithm, the k-nearest neighbors algorithm, and the random forest algorithm. Before we move to the algorithms, let's discuss about the dataset I have used. I have used the UCI spam database, which has a total number of 4601 instances. The total number of spam emails it has is 1813, and the rest of them are ham emails, which are 2788. The total number of attributes are 58 and the number of continuous attributes of word frequencies is 48. The knife-based algorithm. It is a supervised learning algorithm based on the underlying Bayes theorem. The algorithm is trained to use the training data set and it generates a classifier model for us. Classifier model is basically a function to which you provide an input and it basically tells us if that input belongs to a spam email category or a ham email category. It works on the model of conditional probability. Conditional probability is represented as the probability of a certain event occurring if and only if some other event has already taken place. In our case, the spam-based dataset is a continuous dataset, therefore we choose to use a Gaussian knife-based distribution. The graph for this distribution is basically like a normal plot and is a bell-shaped curve. The equation at the bottom of the screen represents basically probability that an email is a spam given that a specific word is present in it. This formula, which is derived from the Bayes theorem, is used in this algorithm. The way we approach is that data is divided into classes. For each continuous attribute present in the data, we find its mean and variance for each class. The formula of probability that a particular attribute is present in a given class is given by this formula on the screen. We find the class probability by simply multiplying, using the assumption that all data features are independent. If the probability of spam is greater than the probability of ham for the test data point, we classify it as spam. The results for this algorithm are as follows. The accuracy is 81%, the execution time is 1.4 seconds, the false negative is 15% and false positive is 2%. Next is the k-nearest neighbors algorithm. The k here represents the number of neighbors we are considering with respect to the test data point. We use the Euclidean distance to calculate the k neighbors. This distance is basically the distance between the test data point and the neighbors. The formula for this is given in this slide and we can see it on the screen. This algorithm is very slow as we are not doing any training phase, and for different values of k we compute distance to each of the other training data points. Once we have our k nearest neighbors, we check if the majority of these neighbors represent spam emails or ham emails, and accordingly we classify the test data point. On the bottom right part of the screen, you can see a picture of how this algorithm looks on as a plot. Here you can see that accuracy and k, which is the total number of neighbors, are related. Here we can see the accuracy is more or less the same. It drops marginally when we increase the value of k. The total time in seconds increases a little as we increase the number of neighbors. This is because as we increase the number of neighbors, we have to calculate distance. We have to calculate the Euclidean distance to more neighbors and consider more classification votes. The results here is as follows. As we increase the value of total number of neighbors we are considering, the accuracy still remains around 80%. The total time taken in seconds is almost 56 seconds, which is a lot of time for this for any kind of algorithm. Hence, for this data set, we can see that this is a very slow algorithm. Next is the random forest algorithm. The general approach of this algorithm is that it creates a bunch of classifiers from the training data set. In this case, the classifiers are basically the decision trees. The classifiers are most effective when there is a general disagreement between them on the input training data set. Since this algorithm deals with a collection of trees, we get the term of forest. We divide a training data set into random groups or subsets. Each of these subsets is used to create a decision tree. Also, the manner in which we traverse the tree to make a decision is in a random order. All of the training data set is not used to create a decision tree, and some of the training data is left behind. Here we can see a plot of accuracy versus the number of trees. As we increase the number of decision trees, we can see the accuracy goes up by a little because we are considering more training data points to make a decision. This is a flow chart of how the algorithm works. On top, we supply input to the different decision trees, and every decision tree processes the input in its own way and votes it as a spam or a ham. Then we combine the votes and see the majority, and then we finally classify the input as a spam email or a ham email. The results in here are as follows. We can see as we increase the number of trees, we can clearly see that the accuracy increases. It goes up to 91%. We also see the total execution time, which is the third column, also increases. This is because now the input has to be processed by more decision trees, and we need to consider more decision tree votes for majority. Before I conclude this presentation, let me show you my code. This is the code for the random forest algorithm. We have a parser which basically parses the user's input. User can provide the number of decision tree he wants in the code. This part of the code is basically dealt by this. Then we come to the main method, which basically the 0.7 over here represents the training to test data ratio. We use 70% of a data set to train and we use the 30% to test our algorithm. After we are done with this, we call the classification method over here. The classification method contains the training size, which is basically 70% of our data set. We generate this part of the code basically generates a random sample out of a training size. This random sample is used to create our decision trees, which is done by this highlighted part of the code. Once we are done with all this, we call the random forest test and train method. The random forest test and train method is used to generate decision tree votes and classify the input as spam or ham. After the algorithm is done with its prediction, we use a for loop, which is this part of the code, to compare the results from our algorithm to the actual results from the original data. This comparison is used to generate the accuracy for the algorithm, which is printed using this statement. We also calculate the false negative and the false positive using these two lines of code. Now let me run this code for you on the terminal. Now, here we have supplied 5 as the total number of decision trees. Here we can see that the accuracy for the algorithm is 91%, which is pretty good for this dataset. The false negative percentage is 6.7, the false positive percentage is 1.88, and the total time taken to execute the code is 0.04 seconds, which is very less for this dataset. Now let me increase the number of decision trees to 15. Here we can see the accuracy is 92%, the false negative is 5.93%, the false positive is 1.3%, and the total time taken increases a little to 0.09%. The increase in total time taken is just because now we have to consider more decision trees, and the input data needs to be parsed through more decision trees to create a majority of votes. This is the code for the naive Bayes algorithm. Here we again split the data into 70-30 ratio as I've mentioned before. The split method is then called, which basically does the same thing. It splits the data into 70-30 ratio for us. Then after that we call the training the algorithm method, which basically generates a classifier for us, which is used to test the testing data. Now I'll run this code for you and show you the results. Here we can see that the accuracy is 82%, the false negative is 14.92%, and the false positive is 2.17%. The total time taken for this algorithm is 0.295 seconds, which is still fairly quick enough, but the accuracy drops down as compared to the random forest. Now here is the code for the k nearest neighbors. Here again we have a parser which basically parses the user's input to basically take into account the number of neighbors the user wants to take for the algorithm. Here again he goes ahead and calculates the Euclidean distance to all the to get the closest neighbors. This is basically the method to calculate the Euclidean distance to all the training data points. Then it using get neighbors method, it basically calculates the neighbors based on the k value that the user has supplied, and then he basically finds a majority, which is done by count label from nearby points, and uses this method. And using this method it basically classifies the test data point as a spam email or a ham email. Now let me show this code for you. As I've explained to you before, this algorithm is very slow, so it's gonna take a while before it finishes executing. Let me give the number of neighbors as 5. Finally, this algorithm has finished executing, and we can see the accuracy is 80.14%, the false negative is 9.49%, and the false positive percentage is 10.36. The total time taken to execute the algorithm is 60 seconds. As we can clearly see that this is a very slow algorithm, its execution time is almost 40 times greater than that of the naive Bayes algorithm. The accuracy for this is almost comparable to the naive Bayes algorithm. Now let me conclude my PowerPoint. As we can clearly see that random forest is the best algorithm for my dataset, since it has the highest accuracy and the lowest execution time. The naive Bayes algorithm and the k nearest neighbor algorithm are comparable with respect to their accuracy percentage, but the k nearest neighbors algorithm is very slow as compared to naive Bayes. So the order of preference for algorithms for this dataset is random forest, followed by naive Bayes, followed by k nearest neighbors. If we change the datasets, the performance of these algorithms may differ. Thank you for listening to me and have a great day.